Fantastic. So my name is Chandler McCann, and excited to talk to you today. We've got 25 minutes in a packed house, so I want to go ahead and kick something off that I'll come back to in a second, just so we can check in where we are when we later on the presentation. So Agile AI and how we can leverage the cloud for automation here. And give me 1 second. There we go. While we get our hotspot internet up. So, as a data scientist, I'm super passionate about how we can leverage AI to improve outcomes for communities around the world. So, in 2018, I was fortunate enough to go to Sierra Leone and Liberia on behalf of the State Department and also DataRobot to work with governments there to leverage AI to improve access to water. In 2019, I launched the AI for Good program at DataRobot, and since then I've seen some really powerful uses of AI, leveraging cloud technology, especially in low and middle income countries, to do things like identify where hospitals and medical facilities should be, increase overall access to healthcare and allow doctors from the West to come in and provide support to those in need. So the promise of technology is there, and it's been a real passion of mine. I've had a lot of luck and joy to be able to participate in this field. At the same time, I've also had the opportunity to work with dozens of customers inside the Fortune 500, some since I joined back in 2017. And that's allowed me to observe a few things. So one, at a market level, what are the trends that have been happening? And two, just also at a customer level, what's their journey been as they go through the phases of implementing AI? And if you're not familiar, DataRobot is the only pure play, full life cycle machine learning platform that goes from data ingest and governance all the way through modeling and deployment development. And that allows our customers really to do two things. One is to experiment quickly and rapidly get to a good answer around what the problem we're trying to solve, and two, scale in a really governed way. And I think we see a lot of companies today that are struggling with getting past that organizational hurdle of 20, maybe 30 models in production. So one of the big drivers of what's been pushing forward the advancements of deployments, especially if you look back at 2017, deployments were fairly rare, and retraining was it was a lot of art and science, right? There was MLOps wasn't really a thing. That was a category we helped create. And if you fast forward to today, we're walking around the conference here, there's a lot of discussion around deployments and the complexity involved with that. And that's been enabled by cloud technology. There are tools available to data scientists that were not available 5-10 years ago, specifically Docker, being able to containerize, serialize models, serve those elsewhere, REST APIs, infinite compute with cloud data warehouses, infrastructure as a service with Kubernetes. These are all massive enablers. So the Legos are there, but we're still not seeing the rate of adoption inside organizations that we would expect with those capabilities. I wanted to ask why, right? And so I think there's a few questions that aren't discussed enough in the community that we should be talking about. In particular, one, how do I increase time to value, right? So this is often thought of as on the front of the AI lifecycle, and around data prep, data cleaning, et cetera. And I call that time to value. Two is time to production, right? So how quickly can I iterate and experiment? And I often see this, and I tell leaders, you shouldn't accept the answer that it's going to take me a week or two to figure out if there's signal in this data set. That's just not acceptable. We're past that as an industry. So, and then the last one, call us time on vacation, right? We want to optimize for this. So who's ever had a model break while they were at home and on leave on vacation, got that phone call? A couple hands. All right, small group. We can all share our war stories here. But sustaining success over the long term, especially at scale, is massively complex. And going from 500 or 50 to 500 models is a real challenge. So let's talk about why here. So demand is increasing, and what we're seeing in the market is a lot of customers getting a little taste of the potential of AI and what it can do for their business, combined with the uncertainty in macroeconomic conditions. And we're hearing a lot of, I want to forecast everything. I want to predict everything. And what that's, unfortunately, the capacity of organizations to provide to meet that demand isn't there, especially with handmade systems. So we are seeing across the board a backlog of models, and these samples are let me adjust this. Is this all right? All right, great. This backlog of models are real things. So there's a huge breadth of applications of AI that weren't the bread and butter use cases of 5 years ago. We recently did a blog post on who's going to score a goal in the World Cup and how to model that, right? Sports analytics is skyrocketed, but some smart players are learning that you need to get on the board of forecasting and understanding your supply chain more efficiently. It's all over the place, right? And recently worked with the Army on how to track their sentiment of their tweets and polarity over time. So the bottom line is that our current team's capacity, I guess raise your hand if you have a backlog of use cases at your business. All right, a couple practitioners. So you understand what I'm talking about. I mean, it's part of our job as data scientists and leaders to deliver value. And that is a function of time, right? And so ultimately, if an AI model necessarily adds value to an organization, if you're doing it right, we would want more of those. And so how do we get there? Well, let's make this concrete. So what we're looking at right now on the screen, a little bit blurry, but these are common tables that are gonna fill up any EMR out there, right? So you're gonna see data around observations, their immunizations, their claims, their procedures, their notes. Like most EMRs are gonna have some flavor of this that's out there. And we've worked with, I've personally worked with dozens of payers and providers, and this idea of high cost, high utilization patients is ultra common on both sides of the fence, and for a lot of reasons. You can improve care, you can drive down costs of the overall health network. But I want to ask you all, to our first question, time to value, how long is it going to take to prepare this data, right? And so one of the things we can do is, and what the cloud can enable, is leverage tools like Snowflake to rapidly understand what we're working with. So in this case, I can see that, and this query ran in 2.6 seconds. Sorry, I'm blinded by this wonderful light here. 2.6 seconds across 3 million plus records, 10 tables, right? That would have been difficult a couple of years ago. So, but that still doesn't tell me what it's going to take to handle this data set. As a data scientist, I'm thinking joins. I've got to be time aware. I've still got to understand the domain of my data itself, and I noticed that there's a lot of text there, so I could explore the amount of text here. And we talk about the power of the cloud data warehouse and this scalable compute idea. Running this regex query 5 years ago would have probably taken 24 hours if it was possible on SQL Server. And so this took, again, a handful of seconds, and we can see some interesting things. I'll just try to make this bigger. Some patients have had over 1,600 visits over this time frame, right? The amount of text in their visit history is over 300,000. For context, that is about the length of Moby Dick, right? So there's some patients with a lot of history. So where do I go from here? I still don't know the answer, right? And part of the punchline is that I still had to, in this case, know to think about the word cars, right? So cars can be indicative of someone having access to travel, someone being in a certain type of accident. And so that's a relevant domain-specific term that I might search for, but I'm far away from a modeling data set. So while the cloud data warehouses are incredible for enabling rapid analysis of data sets at scale, remotely, push-down compute, what I would offer, though, is how do we leverage that and go beyond into understanding which features we should be deriving, right? So there's a lot of FUD out there around data prep existing purely inside of cleaning up missing values, and a lot of that stuff is table stakes, handling your text data, but how are you going to build a modeling data set out of 10 tables quickly? That's going to take some time. And so what we're looking at right now is the ability to, in a time and aware way, and you can see the Snowflake mode enabled here, which is really powerful. Let me zoom in a little bit. So we can link all of those data sets that we care about to our primary data set, which is our latest encounter of a patient. And now I can let computers do what they're good at and automatically derive features for me, right? And so that's, when we think about the data science workflow and time to value, I don't want to, there is a large universe of potential candidate features inside this data set to look at these high utilization patients. And a priori, there is not a great way to do it unless you're a domain expert. And even then, you're probably missing some things. So if you look here, by leveraging the push down compute of Snowflake, I was able to explore 1,500 combinations of features, derive 451 that I think were relevant, and then I can go and evaluate those. So if I go evaluate those, and just trying to pinch out here a second. I start to see some interesting things. So on the one hand, there are my typical features that were brought in from the data itself. Then I start to see the correlation of these features to their target, which is relevant. Like I want to know if there's some signal with my data here. But if I look at, for example, this feature here, this is the days from the start and stop of a medication for a particular patient over time for the last 180 days. So this is basically looking at the total amount of time they're on certain prescriptions, right? And I didn't have to derive this. This was something that was done for me, leveraging the push-down compute of the cloud, looking at the pairwise time difference in an automated time-aware fashion, and allowing me to bypass all the SQL itself. I could push this down, I could store these tables, I could persist these features if I want, but I'm not doing it by hand, right, to start off with. Now, this is something that I think we should begin to expect from our data and our models, our data and our tools. And we can go a step further beyond just looking at one-way correlation. I could start to understand what features are actually driving the predictions themselves. So correlation is great. That's helpful when I'm looking at the beginning of a project. But for example here, looking at the most frequent insurance ID for a patient can be informative. And this is a feature impact chart. Digging into this a little bit, what I notice here is, again, taking the value counts of someone's insurance information over time. But what's popping up? A lot of missing values, right? There's a lot of signal in patients without insurance in the first place. There's a lot of patients that were switching insurance within a 180-day period. Some of these things, again, I don't want to waste my time trying to figure these out by hand. So as we think about what we can do with our some of the tools in the cloud, pushing down the compute, distributing that out, allowing computers to do what they're good at, and to include feature discovery, which is an extremely important part of the machine learning lifecycle, is one way that you can massively scale out the work that your data science team does. And this could be executed on BigQuery, certainly on Snowflake. Redshift has a lot of capabilities in this manner. And here's another example of looking at the pairwise time difference between the onset and the end of an illness, right? So all of these are great examples of reducing the cycle time for repetitive tasks that may not be as value add as it could be. And so what's this look like in the real world? So one of our customers, a top 10 biotech firm, saved 288 person days from their current life cycle, which is very relevant in research, right? I mean, think about the time and the cost of bringing a drug to market. Freeing up that amount of man time by simply collapsing the time to experiment and evaluate certain models, and now is in itself massive. Today, though, they're also able to incorporate visual information. So, I mean, who's comfortable modeling, images alongside tabular data in a really fast way? That would take me a while, right, by hand to do it. It's not impossible, but by abstracting away some of that complexity, leveraging large compute in the cloud to handle the processing, we reduce that cycle time and add value to these firms. So that's a powerful way to increase the time to value. But if we have some data that's useful there, I mean, my question to you now is, how quickly can you experiment and iterate, right? And if you think about what's happening, if you look around at your peers, increase in requests for ML engineers, right, in terms of job postings, increase in requests for data scientists. I mean, people are doing what Google and Apple did in the early days of scaling out their data science teams, thinking I need to throw more bodies at the problem, which is not a bad thing. More people can do more work. However, is that the most cost-effective way? And again, I go back to what is your time to get a model into prod and retrain and deploy? So let's look at this again. So thinking about this use case of high cost, high utilization patients, if I'm solving this myself, there's a lot more than one way to frame this. I mean, I could be concerned about the total cost of their healthcare expenses, model that as a regression problem. I could flip that into a classification problem above some threshold. I could think about their certain diseases and conditions. I could take an unsupervised approach and try to understand, are there specific clusters of patients, and maybe there's some anomalous characteristics that stick out. And those might inform, I would do all of these things if I was trying to solve this for a client or for my own company. And perhaps those clusters would be informative features in a downstream model. So and this is where I see a lot of data science teams slip and not, they settle for good enough, is thinking about reframing your work, and leveraging automation can really help that. So what we saw before is what I was kicking off here was, again, leveraging the push down compute of Snowflake, auto feature derivation, where we're easily able to, and this is just hitting our API, kick off 5 projects here, looking at some of those experiments that we're trying to participate or to execute. And we successfully launched all of those in about 10 minutes, right? So each of those projects is going to include probably 65 different modeling approaches with at least 5 to a dozen or so feature engineering and pre-processing steps. So a huge hypothesis space of what could work. And that's, again, saving me time as I think about scaling up my own self as a data scientist in the field. And if we look over here, so I will just duplicate this tab and open up a new project here in a second. This has been highly efficient for a lot of our customers to think about how you reframe what you're working on and how you can leverage automation to tackle things. So demand forecasting is a really good example. Nestle Mexico had a team that was doing what a lot of teams do, which is leveraging Excel to conduct their demand forecasting. And that obviously is very challenging when you have a lot of SKUs, you have different regions with different customer behavior. And so, but getting to price elasticity within products requires you to get demand forecasting nailed up front. And doing that at a really rough level is going to lead to not great models down the road. So what happened here? 8 data scientists were able to evaluate roughly 60,000 models in a short amount of time and get down to SKU level forecasts in a quarter. So in 12 weeks, they went from not forecasting anything to getting demand forecasting for probably a few hundred of those SKUs in that first quarter, then move that out to their entire product catalog. But their ask for us was, we want to move from low maturity to a mid maturity in terms of AI as an organization. How do we do that quickly? And you do that quickly by, one, aligning the business, and 2, rapidly experimenting on important problems. And they leverage automation successfully to do that. So let's just take a peek at what we were trying to show here. So we kicked off those projects, and just to prove to you that I'm not lying, we can go and see which ones we launched, and we can see, right now. So we have launched these projects that are running. These are all in the background. So the modeling, the encounters, the conditions, our 2 anomaly detection projects, and our clustering one. We'll come back to those when we're done, but in this 25-minute presentation, we're going to have tackled all of these problem sets, and we'll check out the results. So again, thinking about time to production, and if you're spending a lot of time right now, and especially as a leader, if you're noticing your team spending a lot of time retraining their models or trying to debug and find new features to retrain their models, they're definitely not building new projects. And that's a reality we need to come to grips with. So the time to production is highly relevant, and that's been enabled by tools like the Docker and Kubernetes largely. And but what I see is a big challenge in the industry is sustaining that over time. So here's another example. So a large healthcare provider and pharmacy that everyone probably is familiar with, was certainly on the leading edge when it came to deployments. If you think back to the early stages of Docker, like exposing a REST API endpoint for a model was like cutting edge. Like, wow, I just did that, send data, hit it back. I got some flexibility in my deployments. This is great. I didn't have to have someone like boil this down into C, bake it into a system, game changer. But now what they're saying is, like, where did my training data go? Like, what happened to that guy that built the model, right? And so I want to just make a point here. If you want to maximize your time on vacation, a Jupyter notebook is not a production model. There is a lot that goes into it. And I think, again, at a macro level, what we're observing in the market is the proliferation of tooling and teams that have a lot of bespoke components trying to add stability to parts of the system of the ML lifecycle that are becoming really hard to manage. Let's be specific here. Within production AI, especially, again, going from 50 to 500 models, I think a few things are challenging and also super important. One is governance. Two is serving. Three is interoperability, and with respect to being multi-cloud. And then the fourth one is monitoring. And so, to go back to our earlier example, if I wanted to take one of my models that I was pleased with, and I'll go back to our project here. Let's say I want to deploy this model. So unfortunately, we said, what's a data scientist? What's an ML engineer? Most data scientists weren't taught to be DevOps folks, but we're seeing if you're either you're the small organization and you're forced to learn Docker or Kubernetes, or you're in a large organization with a lot of IT rules and they're trying to fit you into their deployment architecture and structure. And the challenge is that data scientists like to code in different things, right? And you should have the flexibility to do what you want to do, right? And so if some people want to use PyTorch, like great. Some people want to use TensorFlow, great. Managing those packages that scale across your enterprise can be a pain. So by being able to easily go and say, if I want to deploy this model, just hit deploy, that's going to expose a REST API endpoint, containerize my model, and I'm off to the races. Ask me about some governments, deployment created, right? Now, that's great, but maybe, that took me 5 seconds, right? I just abstracted away all the DevOps side of deploying a model. I'm gonna have a fully Dockerized, sustained, no training serving SKU when it comes to the data engineering pipeline, out of the box, 5 minutes, don't worry about it. But again, I don't want to necessarily be limited to a certain tool set, and I think everyone's stack is reflective of that. But you should be making architectural decisions that are going to give you some flexibility. So what do I mean? So say that I want to build this model in Vertex, right? And say I want to deploy that model in Vertex on AWS. Well, you're going to come into some challenges. And so, or I want to deploy it on-prem. So one easy thing to do is leverage make some architectural decisions to give yourself an intermediate layer. And here I built a similar model in Vertex. And what I did was upload my model package, my dependencies, and immediately it's going to automate the same process I looked at before. It's going to run tests to understand, hey, am I getting prediction errors? How am I handling null imputations? Things of that nature. And out of the box, hit deploy model, and I'm good to go. Now, we talked about a few things that are relevant for data scientists, and we mentioned governance, interoperability, being able to bring your own model, deploy wherever you want, as well as serving. We touched on those. But if I were to go back to my model here and want to understand what happened, like people quit now. We're starting to see a lot of mobility inside of data science teams, and being able to create compliance documentation, which is stuck due to the internet here, is something that's really important. So I encourage you right now, if you're not documenting your models, start doing that. Get a process to do that. Banks really led the way. And so, but you don't need to be limited to doing that within a certain system. There's ways to pull this out to the tools. So let's jump into GCP here. So let's say that I built my model. I want to deploy this model inside GCP. And another thing that's great about GCP is the orchestration tools are fantastic. And another challenging part of deployments is the fact that I'm going to need to feed that data. I need to score it regularly. And if I look at this training pipeline here, we can see that I'm running predictions and retraining my model on a highly regular basis. And that's great. So, hey, my IT team wants me to use Vertex. Phenomenal. But what I'm also able to do is save that model to my Vertex model registry. At the same time, do what we saw before, deploy that into DataRobot or middle layer, check out my output, and automatically create a compliance document for my own model right here. So within 5 seconds, I was able to create a compliance document that you need a way to communicate with your teams, especially when people leave and you're keeping track of artifacts, something that's highly important. So the last piece, and conscious of time here, the last piece I wanted to talk about, so we touched on how to collapse the time to value. We touched on how to collapse the time to production, and we've all seen this, this gap between, one team wanting to work on something, where it needs to be deployed, and this idea of having a middle layer in between. But what's true is ultimately models drift, and this is a real example, right? So a company was trying to avoid fines for late shipments, and over time they deployed an AI model that got better progressively, at avoiding those fines, avoiding those late shipments. But that model degraded, and we find on average on our cloud, models tend to degrade 5% a year. In this case, it degraded 17%. This person actually got a phone call on vacation. So you want a common way to monitor these things, and a real challenge for companies, and to take a peek here, is having a simple pane of glass, right? So you're going to have deployments all over the place, and so you want to be able to monitor and keep track of those in a very simple way, and being able to look at sort of like a IT ops dashboard of what's my deployment health for my service, is my data drifting, is my accuracy degrading, is really powerful. So, for example, same thing, looking at my Vertex model that I was able to deploy inside AWS, I could easily go in, look at the model lineage, check out my drift over time, start to debug why my model was behaving differently between training and serving, where my data is shifted. And in this case, we can start to drill into the variable level. But ultimately, you want to have again, this common, there's a lot of risk to adopting an MLOps that's solely integrated into one ecosystem, due to the fact that your team is hardly ever going to want to operate in one ecosystem. It's going to be flexible over time. So coming up on the end here, and I want to just leave with two last points. So your models will drift. Ensure that you're monitoring them. And when we look at key architecture, most cloud or hyperscalers are going to do the blue boxes. Most or all of them do the blue boxes. They do different shades of the white boxes at varying levels of ease of use. And again, we found having an experiment layer and an MLOps layer in between helps collapse that time to value. And as you make architectural decisions going forward, there is a long-term impact of being embedded in. I have yet to meet two things. One, a cloud migration that has gone like that. You're going to have data on-prem and in the cloud, and you're going to need hybrid monitoring and deployments pretty much all the time. Two, everyone generally tends to go multi-cloud anyway. So, the interoperability of models across clouds is something that's a challenge. But three, you want to have flexibility. You want the right tool for the job. And so that's how you maximize the output from your team. So where can you accelerate? Cloud data warehouses can drive compute and scalability across tasks that we think are the domain of human knowledge. And I want to challenge everyone to think that to look at feature discovery and prototyping as not just the area of the domain expert, right? There's ways we can leverage automation to help here. You want to give yourself a governed layer for all of your team to work with, and maintaining that flexibility for deployments is super critical because your team is going to want to continue to operate in different toolings, and you're going to need to be able to monitor on-prem and across multiple clouds as you scale. And so That's how I think about Agile AI within the cloud infrastructure. I don't think we have time for questions, but I appreciate everyone's time today. Enjoy the rest of the conference and take care.